Hello, calculus fans! Alright, let's try to prove the formula for the volume of a right circular cone of base radius r and height h. Now you might know this formula. It's 1/3 pi r squared h. We're going to try to prove it now. Of course, a cone is not a cylinder, so we're not going to be able to just apply our cylinder formula. Let's go ahead and orient the cone like this. So I'm tilting it on its side. So the height is here, the base radius is here. The cone is going to get sliced perpendicular to the x-axis. So what I'm pointing to there is a slice of the cone. When we slice a cone perpendicular to the x-axis, the slice is a disk. Actually, more accurate to say that it is very close to a disk. Now we need to figure out the radius of this disk. If the disk has radius p, then the volume of the slice is delta v equals pi times p squared delta x. Remember, the delta x is the thickness of the slice. I'd like to find an equation of the top bounding line of this cone. So if you think about the picture, then the cone really looks like this, but we're just looking at the top bounding line. The coordinates of this point here are h comma r, because remember that this distance here was the height and this distance here was the radius, and so we have a line y equals r over h times x, because the slope of that line is r over h. Alright, now we can see that the radius of the slice is p, which is equal to y, and y is equal to r over h times x. So from all that, we can write down a formula for what delta v is. Delta v is pi times r over h times x quantity squared times delta x. Remember, delta x is the thickness. And then if we work all this out, we get pi r squared over h squared times x squared delta x. This is an approximate volume of a slice of this thing. Once we know what the slice looks like, we can write down formula for the volume of the cone. So the volume is going to be the integral from 0 to h. So that's 0 to h because that's how far we had to move along in the x direction. And then we just integrate our formula for the volume of a slice. Pi r squared over h squared times x squared dx. This is easy to integrate, keeping in mind that this thing here is just a number. So we really only have to anti-differentiate x squared. So that turns into x cubed over 3. We plug in the 0 and the h. If we plug in 0, we get nothing. So we'll just plug in the h. And a couple of the h's cancel. And we get our final answer here, a formula for the volume of a right circular cone. And this is a proof now of the formula for the volume of a right circular cone. Well, interesting historical side note, Archimedes knew how to calculate the volume of a cone, but he did not have calculus at his disposal because Archimedes lived thousands of years ago, long before the discovery of calculus. So it's pretty remarkable that Archimedes was able to determine a formula for the volume of a cone. Archimedes also knew how to compute the volume of a sphere. Okay, that's all for now.